Okay, again, the next we discussed two important issues that econometric model has to define. And the third issue econometric model has to be dealing with is exogeneity or endogeneity. So in general, it's not about not only in statistics, but in general science, exogenous variable is defined as a variable that is not determined, not explained by the model. So, for example, in our linear regression model, x is exogenous because we do not know how x is generated. So, for example, we are interested in the linear regression of salary on your education. Then this model is to explain how the salary is determined. I don't know how we do not care about how the education is determined. So education is exogenous variable in this case, right? So later we are going to relax that assumption, but just conceptually. So exogenous variables are just given. It's assumed to be given, exogenously given, maybe random or maybe fixed, but I don't care. So that I don't know how it is generated, just it's given. On the other hand, the exogenous endogenous variable is a variable generated by the model. So in the regression model, y is an endogenous variable. So the wage is determined by the education, so that is endogenous. The model explains how the salary is determined. That is a general scientific definition. And in a smaller scope, in regression type models, usually exogenous variables refer to the variables that are not correlated with the error terms. But endogeneity implies correlation with error terms. So basically the intuition is the same, but often this regression model definitions for restrictive definitions for regression models, it's a simple way to tell whether a variable is endogenous and exogenous. And as I said before, the exogeneity assumption, this implies covariance between x and epsilon is 0. So in that sense, uncorrelated, so it's exogenous. X is exogenous because epsilon is the only error term here. All right, so these three questions are important to be specified by an econometric model. Okay, then assume that we have an econometric model. Then how can we discuss identification? The concept of the research on identification does not have a long history. So there are some statisticians and econometricians who think about identification like decades ago. However, at that time, identification was not an important issue because when models are simpler, when an econometric model is simple, in many cases identification is obvious. You don't need to worry too much about the identifications because the assumptions are obvious. You know how it's identified, and the role of assumption is quite clear. But later on, like after 2000, an econometric model becomes more complicated, like non-parametric model or simultaneous equations model. Several equations have to be estimated together. So identification becomes a problem, a real problem. So as I said, so people encounter some like econometricians see some unnatural results, some problems, repeated problems in similar models, but it was not about data. So they found the problem was coming from assumptions and so identification failure. So the research about identification has been done, very actively done, maybe late 1990s and through 2010, mid of 2010s. And there is a nice survey paper reference by Rosa Matzkin in Handbook of Econometrics. So a survey paper, paper is usually about, the published papers are new results. So when you develop a new results using new data or new assumptions, new models, then it will be published in a journal. That's called a paper. But when a survey paper is more about review. The survey paper is written usually by some big names, so who understands the literature very well and summarizes and kind of organizes the arguments in the same literature, so that young students like you or young researchers can learn or can review the literature quickly. So using survey papers as an introduction to identification would be really, really helpful. But it's very theoretical, so I'm not going to require you to read it. But reading, if you are interested, surely you need to read it if you plan to kind of specialize in this topic. Okay. And then let me define. So Wikipedia has its own page. You may just read through this. But when I say, let me define it more easily in one sentence. When I say a parameter is identified, or when I say a parameter is identified, it means that if I have infinite number of observations, then I can uniquely determine the true parameter. So, right, I'm not confused with the wrong parameter value. I can guess the true parameter correctly if I could have unlimited number of observations. That's a very casual, roughly speaking, this is what identification means. So this is intuitive. More rigorously, let's think about the problem. Basically, estimation is kind of solving something for the unknown parameters. We'd like the solution for the unknown parameters. And mathematically, what we have, the available information is the assumptions and the data. And from the data and the assumptions, we have to solve for unknown parameters. So it's like solving equations, exactly. And then in general, in mathematics, solution to solving an equation or solving a system of equations have two potential problems. First, existence. Some mathematical problems don't have any solutions. Like, for example, x plus y equals to 0 and say x plus y equals to 1. These two equations don't have any solution. There is no pair of x and y that can satisfy both equations at the same time. In that case, we say the solution does not exist. On the other hand, there is a uniqueness problem. For example, when I have a system of equations like x plus y equals to 1 equation, and second equation is 2x plus 2y equals to 2. Then, in this case, we have two equations and two unknowns, but there are infinite number of values that satisfy those two equations, because those two equations are basically one equation, so the solution cannot be uniquely determined. So that's the uniqueness problem. And that's just general mathematics concept. And in our case, let's first think about uniqueness. Uniqueness is a more problem in estimation. So for example, you have we would like to study how the wage is determined. Suppose that the wage is determined by your work experience or your education. Say experience and your education are the only two factors that determine the wage. The uniqueness problem, if the solution is not unique, if the model is not uniquely identified, that means you have to tell which factor is more important. Like for example, the slope of work experience is more important or education is more important. If you cannot tell which is correct, the uniqueness problem arises. So you have to tell exactly how much more important to have one more education is than having one more experience, right? So you have to give one number that you obtain from the data. That is what we usually worry about in this chapter. Well, at the same time, non-existence is a concern at the same time. However, it's not a big problem usually because when we have the data, that already means there must be parameters. So wage is determined by education and experience. Then there must be some relationship. We cannot. So how can we think non-existence in this case? The only problem here is whether the assumptions are correct or not. So, for example, we assume that there are only two factors, but there may be those two factors are not true factors, but other factors are more important, and these two are not the important factors. So non-existence problem is less of concern in identification chapter. This is a more mathematical explanation, still very rough, conceptual explanation of identification. So we would like to solve for unknown parameters from the data. That's the basic structure, and we need to concern uniqueness and existence, and especially the uniqueness is a main concern. And even more casual explanation. So this is purely theoretical and mathematical definition, but in the seminar, the question and answers go in a different way. For example, when I like in a seminar, applied seminar, it goes like this. For example, question: someone asks the speaker, how did you identify beta in a regression model? Then the speaker may explain something like that. Suppose that there are two identical individuals, but they have different x, but otherwise identical. Then comparing their y will yield the effect of xi. This is how we identified the effect of x. For example, let me put the idea in the example of wage and education example. So how can we identify the effect of education on wage? Then my answer would be, suppose that there are two identical individuals, but one person have 10 years of education, 12 years of education, and the other person has 13 years of education. So the difference is 1 year. And if we compare their wages, then the wage difference would be the difference in their education, right? Because everything else is the same. So comparing these two people will identify the effect of education. Roughly speaking, this is how we intuitively understand the identification mechanism. So, and in the next video, I will go deeper and to more rigorously define the identification, we need a little more concepts for the definition. So let me do that in the next video. Thanks, bye.